Welcome to Demystifying Math. In this lesson, we're going to be discussing conditional probability. Conditional probability is a probability that one event happens given that another event has already happened. We have the numbers 1 through 8 written on pieces of paper, and the papers are placed in a hat. One paper is chosen at random. What is the probability that the number chosen is odd given that it is a number less than 6? We're going to let A equal the number is odd and B the number is less than 6. Since we already know that the number is less than 6, we're only going to choose from that set of numbers. So we're going to choose from 1, 2, 3, 4, and 5. 3 of those numbers are odd, so our probability is 3/5. The formula to find a probability given that another event has already happened is the probability of A given B is equal to the number of elements in A and B divided by the number of elements of B. The number of elements of A and B in this case is the number of elements that are both odd and less than 6. So that's 1, 3, and 5. So there are 3 of them. The number of elements in set B are the number of elements that are less than 6. And that's 1, 2, 3, 4, and 5. So there are 5 of those. So all we have to do is divide 3 by 5. One card is randomly selected from the bag. What is the probability that the card will have a circle on it? There are 6 cards in the bag and one has a circle on it. So there's 1 out of 6 is our probability. Now let's suppose that we're given extra information. What is the probability that the card will have a circle on it given that it has an odd number on it? This is like saying we already know it's odd. So we're not going to look at the even numbered card, which is the 2. We're only going to select from those 5 that are remaining. So the given gives us our total possible outcomes, or our denominator, when we're finding the probability. So we're looking for a circle given that the number on the card is odd. There are 5 cards that are odd, and there's 1 card that is a circle with an odd number on it. So our probability is 1/5. What is the probability the card will have a 5 on it given that it has a triangle on it? In this case, we only want to consider the cards that have triangles on them. And there's 3 of those. Out of those, we want the ones that have a 5 on them. So there's only 1 that has a 5. So our probability in this case is 1/3. What is the probability that the card will have a triangle on it given that it has a 5 on it? In this case, we're only going to be considering those cards with 5s on them, and there's only 2 of those. Then we want to figure out which one has a triangle, so there's 1 out of the 2. So our probability is now 1/2. Suppose that the table represents the results of a survey conducted in a city where residents were asked what type of cell phone they used. So we have cell phone types A, B, and C, and we have age ranges given. We want to find the probability the citizen uses type A given that the person is over 60. Since we already know that the person is over 60, we're only going to consider that data. Those that use type A would be the 100 in the A column, and the total amount would be 271 since we already know that the person is over 60. Let's work with this in the other direction. What is the probability that the citizen is over 60 given that the person uses type A? Since we know that they're using type A cell phones, we're only going to use the data in column A. So we have 100 still as our intersection of A and over 60, but we have 716 as our possible outcomes, our total possibles. So it's 100 over 716, or 25 over 179 in lowest terms. Thank you for watching.